All right, yeah, welcome back again. If you remember, last time we did a parametric test of a two sample pairs test, a PAT test for parametric test when the parametric assumption is assumed. So if you have not watched that, you can go ahead and watch that so that you can understand the background and the explanation I give there, which is detailed. Here, I just want to show you the other way to do it, which is a called non-parametric test. When the parameter assumption is not assumed, cannot be, it's not in conformity. So that is purpose of this particular one. So don't forget, I explained last time that it is called dependent two sample test. All right, that's a PAT test, dependent, and it uses one numerical variables and a one paired group variable. You can see the data here. This is actually the data. All right, in R, this is how it is arranged in R, but not in past. In past, you have to regroup it in past. This particular group now, this is before, and this is after. You can see after here, before here. So you have to rearrange them, but this is the before. So the before, you have to bring all this one down to before, or before here, then after under it here. So that is in past. This is past arrangement. Okay. So this past arrangement. So now we are going to first check the assumption first. Okay, if it using a Shapiro test, so we can copy this line first. Let's copy this line to past and check if the you can make the assumption. Let's first check first. Okay, let me just copy this one and paste here. Oh, sorry. All right, so I just select this now. I go to univariate normal check. So when you look at Shapiro here, 0.0000.0003, which means highly significant, which means it failed the Shapiro test. Okay, it failed, right? Even Anderson test is failed. Monte Carlo also failed. So you can see all of them, it failed, which means it's highly significant, and which means it does not meet parametric test assumptions. So therefore, we cannot use parametric test for this particular one. So we have to use a non-parametric test. So that is we have to use Wilcoxon in past. So the way we did in HAR, then for those some of you who watch the HAR videos, you see that the same way you can do in past in a very simple, easy way in past. R Studio, you have to compute some code, but here just run a click. Just click, and it gives you the result automatically. So let's see how to generate the result here in the past. All right, so I just new, click on new so that I can clear the space. So now I come here, I copy this. This is the data I'm going to use here. Okay, I just copy this data. Now I go to past. I select this, I click here. Right, so I paste. So I uncheck. So I select the two together. So I want to use the two together now, these two together. All right. So now I just run the test straight from here. Go to univariate here. Go to two sample test. Click on the two paired test here. So we have come here before, but we didn't actually go down here to see what is happening here. All right. This is for parametric test and for non-parametric test actually. So Wilcoxon test for stochastic equality. We won't forget that in the two sample pair test for parametric test, we use mean. All right, it uses mean to find the value, because what we're actually doing that we are finding we are comparing two related or dependent samples that we are comparing. No, which is have before test and after test, before experiment and after experiment. That's what we are doing right now. So, but we in the parametric test we compare by mean. But in non-parametric test, we compare by median. That's the difference, okay? You can see a median here. You can see there's a mean here. So that is what it's doing, all right, for non-parametric test. All right, so when you look at this now, it's talking about comparing the median of two related or dependent samples, all right? So when the data is not normally distributed, that's what it means, okay? And maybe you want to know if there is any significant difference in the media weights, okay, of the subjects or the sample, okay, before and after treatment. That is what we actually try to do, which we did last time. So we can see here the W here, we constant value is 0 here, and we also have our p-value here is very significant, 0.00 0.0000, and even the Monte Carlos for the one is also highly significant there. So you can see that this is the result we got here for Wilcoxon, which is a non-parametric test of a pair to sample PAT test. So it is CC, and the result is the same with R actually, because if you check, you have W0 here, and we have here we have p-value here, this one 0.00174. So if you check here our result here, you can see here we have V0 here for the same data, and we have 0.0000184. So it's very similar, highly significant as well. So that is just the difference between the two, and you can actually get your result very easily using PASS, and this also PASS have confirmed with you that it's very accurate, very authentic, and you can use it at any time. So I will see us in the next video as we look at something else, something different. Thank you so much for listening. I'll see you in the next class.